Hello, I'm Carrie Gorman,
And I'm Blaylock.
and we will be discussing if ammonia is a viable fuel for the future.
One of the major issues that's present in the environment today is the amount of carbon dioxide created by humans. These emissions are raising the temperature of Earth significantly, and the only way to solve this issue is to reduce the amount of carbon dioxide produced worldwide. One of the main contributors of emissions is the transportation industry. In the past, the million-dollar idea was hybrid vehicles, and this was created to help solve this issue. But this idea is not happening as quickly as needed. This is an issue that needs to be solved now, so the discovery of a new fuel is necessary. Currently, the combustion process that happens with fuel is producing carbon dioxide as one of the products. This happens every time the car is turned on, so when you take the number of cars started every day, that number adds up quickly. The goal to discover a new fuel that eliminates carbon dioxide is necessary.
So where is ammonia used if it's not being used as fuel in cars? Well, ammonia is produced for a very wide variety of uses and is one of the most commonly produced industrial chemicals that you may see in laboratories today. And the largest area where ammonia is used is in fertilizers, which means that the agriculture industry relies heavily on NH3 or ammonia to grow crops or feed livestock. And some of the other areas where we may see ammonia are in cleaning products, refrigerants, and in energy production. So power plants use ammonia sometimes to produce energy.
So looking at the characteristics of ammonia, within the structure, there is one nitrogen atom surrounded by 3 hydrogen atoms. And if you look at that structure, you notice that there's no carbon atoms, which is a benefit because we're trying to eliminate the amount of carbon dioxide produced in fuel, so that since there is no carbon present, that is a plus. Some more characteristics are that it has a distinct smell and is easily detectable. So that means if there is a leak, it would be very easy to smell ammonia and realize that there is a leak. It dissolves easily in water, and lastly, ammonia is corrosive, which means there might be an issue with storage, but it's not too toxic, so that is not a large issue.
For ammonia to be used as fuel, it needs to combust inside of an engine or cylinder. And the combustion of NH3 ideally is just NH3 reacting with oxygen to make water and nitrogen gas, which is the most abundant component of air in our atmosphere. But unfortunately, the combustion of ammonia is not ideal. Ammonia is a molecule that easily oxidizes, and as you can see in the chart below, there are many different ways ammonia could possibly oxidize before it reacts in an engine or cylinder. That means that not only do we get nitrogen gas and water as products, we may also get NOx gas as a product of the combustion of ammonia. Nitric oxides or NOx gas is released in the incomplete combustion of ammonia. It is dangerous to humans because it is poisonous if inhaled, and it reacts with volatile organic compounds in the atmosphere to form ozone in the troposphere, which we call smog. And smog blocks sunlight and traps heat just like any other greenhouse gas, which is exactly the problem that we have when we release carbon dioxide in the atmosphere. That is why it is so important to limit the amount of NOx gas released in the combustion of ammonia so we avoid its indirect effect to creating greenhouse gas. So what are the advantages of using ammonia in conventional engines? Well, green ammonia, which is ammonia produced without release of greenhouse gases, could produce just 1/3 of emissions of regular hydrocarbon fuel that we use right now, which is exactly the problem we're looking to solve. And complete combustion of ammonia produces nitrogen gas and water, and not any carbon dioxide. Ammonia is also safe to handle and transport and is commonly handled and transported all around the world.
It appears that ammonia would solve all of our issues currently in finding a clean energy fuel source. But just like any other fuel source, there are challenges with using ammonia. There are 3 major issues, and those are high ignition temperature, low flame velocity, and slow chemical kinetics.
One major challenge encountered by using ammonia as fuel is its high ignition temperature, and its ignition temperature is the temperature at which a fuel can combust. And in ammonia, its ignition temperature is higher than what we see with traditional gasoline. That means that more power is required to heat NH3 to its combustion temperature. And our current engines are not equipped to do that, so it will require extra technology. Another challenge is ammonia's low flame velocity, meaning that ammonia ignites slower than other fuels, and it may take longer for ammonia to travel through the car than traditional gasoline. This also causes a loss of power due to slower temperature diffusion inside the cylinders, meaning that the whole cylinder is not heated up at the same rate or a similar rate, and it will take more time for the entire cylinder to reach the same temperature, meaning there is a loss of power in the engine.
And the last issue is that ammonia has low chemical kinetics. So basically what this means is that ammonia may not combust before exiting the automobile. So ammonia would leave before the reaction even happened. And another thing is that due to the slow chemical kinetics, this requires a catalyst to speed up the reaction rate. So in order to increase the slow kinetics, that catalyst is necessary, and that is a problem because it's another additive to the fuel that is necessary.
Scientists have developed some potential solutions to address these challenges we have when trying to combust ammonia in an engine. One of these ideas is to, in a compression engine, mix ammonia with traditional gas to increase the efficiency of the combustion of the ammonia.
Another solution is through using combusting gasoline to preheat the ammonia. This would decrease the amount of energy required by the engine to combust ammonia.
Another necessary idea would be to develop a blender to mix the NH3 and the traditional gasoline in a cylinder where they could combust together. And the goal of the blender would be to carefully balance the amounts of gasoline and NH3 in the cylinder to maximize power while minimizing emissions.
Another idea is to add a supercharger to the car to increase the presence of oxygen to combust ammonia. This would help increase the flame velocity by allowing more ammonia to combust at once.
And finally, to increase the speed of the chemical kinetics, they could incorporate a catalyst to speed up the reaction of the combustion of ammonia. And this catalyst could just be used as an additive to the existing fuel. One of the solutions was to blend ammonia with traditional fuel, and studies have shown that carbon dioxide emissions of gasoline mixed with ammonia decrease with the increase in ammonia content, but the nitric oxide emissions increase. Also, the energy and the efficiency of engines reduce with greater ammonia content. It is possible to blend ammonia with hydrogen, and that would eliminate all carbon dioxide emissions in combustion. But there would be difficulty with transportation and storage of hydrogen on account that it is highly flammable. Also, Japanese scientists are working on ways to cleanly combust pure ammonia, but that has not been able to be done yet.
To conclude, ammonia could be the answer to reducing the carbon dioxide emissions from transportation. But in order to do that, developers must address 4 things. First, developers must provide green ammonia to consumers made with 0 greenhouse gas emissions, because the current issue is that there is too much greenhouse gas emissions in the atmosphere. Next, they must create blenders to carefully balance the proportions of gasoline and ammonia entering the cylinders. Another thing that must happen is developers need to find ways to capture nitric oxide gas before it enters the atmosphere and creates smog, because nitric oxide is poisonous and smog indirectly creates more greenhouse gases. Last, developers must equip gas stations with ammonia and teach consumers how to use it in their vehicles.
Thank you for watching our presentation, and we hope you learned a little something about the future of fuel.